Welcome back to the class. Now we will talk about mountain building. We will look at all these different mountains across the globe and what are the geological processes responsible for the formation of these different mountains. We will look at three major mountains systems, one in Western Pacific or Western US border or North American border, west coast. We will look at those mountains. We will look at mountains, Andes Mountains on the South American Pacific side, and we will look at Himalayan mountain, and we will see try to understand that how these mountains came into existence, what are the geological processes responsible for these for the formation of these mountains. It has been a matter of curiosity, a kind of a mystery to everyone in the past, that how these mountains came into existence. So we will try to answer this question in this session now. There's a term called orogenesis that describes all the processes responsible for this chain of mountain that we see on the face of Earth, and all of these mountains are not always about the same age. They some are older, some are younger, and that is what we will try to understand, that how it all happened. Some of them have come at different time period. So we will look at these young mountains in this chapter. So this North American Cordillera, Andes Mountain, and this Himalayan mountain that runs along Mediterranean coastline and Indian subcontinent. So these are the three mountain systems that we will look at. These are relatively young mountains. The other ones, the older ones, are these Appalachian mountains or Ural mountain, and some of these in the Baltic region or in the Greenland region. So these are much older mountains that came into existence much earlier than these younger mountains. So we will focus. This chapter is dedicated to the formation of these younger mountains. Shields are special or very characteristic type of rock deposits that we see on our different part of planet. They are characterized by unique type of rocks and minerals. So that is how we define shields. And we will see that how they came into existence, what are the different types of shields on our planet Earth. Where are Earth's major mountain belts? Young mountain belts at convergent boundaries. So most of these or all of these mountain belts that we will look at today, they are at the convergent boundary. So remember, in plate boundaries can be of three different types: divergent boundary, convergent boundary, and transform plate boundary. So all of these mountains that we will look at today, they are all at the convergent plate boundary. Like here on the west coast of North and South America, the Pacific Oceanic plate is converging against the North and South American plate. Here the Indian subcontinent or Indian plate is here we can say Indian Oceanic plate is subducting under this Eurasian plate. So this is what is responsible, these convergent boundaries responsible for the formation of these mountain belts. So we can divide these three mountains into these three different unique system. North American Cordillera, this is the one kind of special geological processes that leads to the formation of these chain of mountains along the east coast of west coast of North American plate, Andes mountain. These are characteristically different from these North American Cordillera type mountains. So this is another set of processes that leads to formation of these Andes mountain. These are also along the west coast of South American plate. This third one, the Himalayan mountains, these are also very different than Andes mountain or North American Cordillera. So we will look at how they are different from each other, even though they are all formed at the convergent boundaries. So let's first look at the Andean type mountain, which is on the west coast of South American plate. Here we know that the Pacific Ocean is subducting under South American plate. So here you have oceanic lithosphere. Oceanic lithosphere is much denser than the continental lithosphere. So when they collide, or when they meet at a convergent plate boundary, the oceanic lithosphere will descend into the mantle, and that is where it will create this subduction zone. And as this subduction plate, it is descending into the mantle. It's about 100 kilometers, which is about 62 miles below the ground. As it reaches that depth, the partial melting will begin. So this oceanic lithosphere will start to melt as it descends about 100 kilometers or 62 miles into the volume of the earth, or into the mantle of the earth. So that is when the magma will start rising. As the rock will starts to melt, it will create magma, and this plume of magma start rising toward the surface of the earth. So what will happen, lots of these magma plumes will not make it all the way on the surface of the earth. Instead, they will starts to solidify as it reaches near the surface. But some of them do break through on the surface of the earth in the form of volcanoes. So that is how you will get this chain of volcanoes. Right. So here in this example, you have oceanic plate, and this is another oceanic plate. So you got this volcanic island arc. Right. So this is also ocean, this one is also ocean. Both are oceanic plate, but the older one will be denser than the younger oceanic plate. So the older oceanic plate will descend, and the younger oceanic plate being buoyant, it will not sink into magma. It will remain afloat or buoyant on the surface. But the denser one, as it sinks, it will start to melt at a deeper depth, and then the magma start rising, and sometime it break through, and then it creates this series or chain of island arcs. So this is how you get this volcanic island arc, or series of volcanic arc in the middle of ocean. Continental volcanic arcs form at Andean type convergent zones before subduction sediment accumulates on a passive continental margin. So now let's look at the detail about this Andean type mountain building process. So here you have oceanic plate here on the left, and continental plate on the right. This is your continental lithosphere, this is oceanic lithosphere, and right where the ocean meets with continent, there is this continental shelf, and then you have a continental slope here where the depth of the ocean suddenly changes, and this is where the oceanic crust or oceanic plate will meet with the continental plate. So the idea is again very much similar. The oceanic plate being denser than continental plate, it will start to subduct into the mantle, and as it gets to about 62 miles into the depth of the earth, it will start to melt. Partial melting will begin, and that will start forming magma. The magma being buoyant, it will start rising toward the surface, and this plate is still subducting, and as it is subducting, lots of this sediment is being scraped because the bottom of the ocean has lots of sediments, and this oceanic plate, as it comes close to the continental plate, the continental plate will remain stationary, but the oceanic plate, as it is subducting, it will act like a bulldozer. Like I've put this picture here just to illustrate that, like this front plate of the bulldozer, it will remain static and will just pick up all the sediment from the ground. So this is exactly what happens here. The continent will scrape the sediment off the face of this descending oceanic plate. So you have lots of these sediment start depositing on the continental shelf here. So you have this continued deposition of sediments on the continental side of this continental plate, and over the years this continental shelf will continue to see more and more deposit on the continent side, and then the site of subduction will start to move further inward into the ocean. So that's why now in the case of Andean type mountains, you have these two characteristic features. One is the chain of volcanic arc here because of this descending oceanic plate. There is a partial melting, the plume will start to rise, and then some of them will break through, and that will create this chain of volcano or volcanic arc on the face of Earth. And then you have lots of these intrusive plutons. These are intrusive igneous rock. You might remember that term from the chapter rocks, where the type of igneous rocks which is solidifies in the interior of the Earth. So those are the pluton, and when you have these group of plutons, this creates a very massive plutonic or igneous structure called as a batholith. And over the years of erosion and some tectonic activity, this may be uplifted, and when this group of plutons is exposed on the surface of Earth, we call it batholith. So this is the mechanism of Andean type mountain, where the oceanic plate is subducting under the continental plate. The continental plate will scrape off the sediment from the face or the bottom of the ocean. The sediments will be deposited. The oceanic plate will subduct, and it will create this series or chain of volcanic arc further inland. So there is a lot of sediments deposited here, and then you have this basin, which is the ocean water, and over the time it becomes fresh water by means of more and more rainfall. As it accumulates here, it will start to become fresh water, and then you have this chain of volcanic arc here, which is further inland on the continent side. So this is one model which describes the Andean type mountain. So remember that this is an important question here. What are the major features of an Andean type mountain belt, and how are they generated? So these are the major features: continental volcanic arc and accretionary wedge. So I want you guys to remember that these two features from the Andean type mountain belt. Now the second one is what are the stages of development in a collisional mountain belt. So the second type of mountain belt that we will see are collisional mountain belts, where again the oceanic plate is colliding against continental plate, and then there's a slight difference between these two collisions. The one that we just saw in the Andean mountains, there's a little bit of difference between Andean type mountain and Cordilleran type mountain that we see on the west coast of North American plate. Cordilleran type mountain building occurs in Pacific-like ocean basin. Rapid sea floor spreading is balanced by rapid subduction. So there is a divergent boundary on the other end of the Pacific plate, and on the side where the Pacific plate meets with the North and South American, that is your convergent boundary. So the rate of spreading from the divergent boundary is same as the rate at which the plate is subducting at the west coast of North and South American plate. Island arcs and crustal fragments, these are called as terrains. So this is very well defined here. So there are islands in the middle of ocean, right? Just like Madagascar island, or the island that we see in Indonesian island in Pacific Ocean, or Japanese islands. So those islands have a specific geology of the rock, and those specific unique crustal fragments are called as terrains. When what happens in this kind, so when this oceanic plate is now subducting under here, now this is bringing these microcontinents closer and closer to the continent. So as this plate is subducting under the continents, it is bringing these microcontinents closer toward the continental plate. And here you can see that it is becoming even much closer now, as the oceanic plate is subducting under the continental plate. Here now you can see that the microcontinents have just become very near this subduction zone. And what will happen as it comes close to the subduction zone, this is much lighter. This microcontinent, the density of rock on this microcontinent is relatively very light compared to the oceanic plate. So this microcontinent are not going to subduct because they are lighter, they are buoyant. So what will happen, these microcontinents will start depositing on the continent. So in the Andean type mountain, we had the accretionary wedge that was formed from the sediment at the bottom of the ocean, and here we have this deposition made from the microcontinent. So as these microcontinents come close to the subduction zone, instead of subduction, they will be just simply deposited on the continent. So what will happen, this will continue to shift the subduction zone further inland, further into the ocean, because now all of this become part of the continent. So it's in a way the continent is growing in size due to the deposition of these microcontinents. And again, in the similar, just like Andean type mountain, further inland you will have these volcanic arc here. Due to the subduction of this oceanic plate, there will be a plume, magma plume. The magma plume will rise toward the surface, and you will have this volcanic arc that will leave behind. You have chain of mountains here. This is also a smart figure in your textbook, so please browse through them. There is a very nice animation that explains this whole process of Cordilleran type mountain building. This is the third type of mountain building called alpine type orogenesis, results from continental collision. Okay, so collisional mountain belts are a special kind of mountains that are formed when two continental plates collide. And here we will look at the example of formation of Himalayan mountains. So what happened here about 50 to 30 million years ago, yes, look at this map. So India, this used to be a Gondwana land here. It was used to be part of African continent, and this Indian subplate, it broke off here just like Madagascar from the African plate, and then it is started moving northwards. So it is sitting on Indian Ocean, and Indian Ocean is subducting under this Eurasian plate. And since this Indian plate is sitting on the Indian oceanic plate, the oceanic plate is moving northward, so it is carrying this Gondwana Indian plate northward along with itself. So Indian subcontinent is just riding on top of a moving oceanic plate. So that is the idea here. So now let's go back to the schematic. Okay, here it is. So this is how the Indian subcontinent plate it is approaching the Eurasian plate here. This is the subduction zone. So this ocean will be start to closing in here, right? So because this Indian plate, as it is, starts to converge toward this continental Asian plate, this ocean will start to close in, right? So you can see that in the next figure here, the Indian plate has now collided with the Asian continental plate. So because this subduction of the oceanic plate, it will continue to pull this Indian plate towards the Asian continental plate. So the Indian plate itself will not subduct because it is lighter, it is buoyant. So the oceanic plate will subduct, but the Indian, which is a continental plate, it will not subduct. So it will just kind of collide against this Asian plate, and due to this collision, you will have this formation of mountain, and there will be a thrust fault range, and then you have lots of folding here. So you have lots of these geological features that will form right here due to the collision between Indian plate and the Asian plate, and both are continental plates. So this Tibetan plateau, it is believed that it used to be some kind of a microcontinent here in the ocean, and before this oceanic plate subducted, it just simply deposited that Tibetan microcontinent on the Asian plate. And when Indian subcontinent came from behind and it pushed it, and then it rose even higher in elevation. That's why Tibetan plateau has such high elevation, because first it was deposited and then it was pushed against the Asian plate, and that led it to rise even higher in the elevation. And that collision between Indian plate against this Eurasian plate has caused this expansion of Chinese region here. So mainland Southeast Asia and this eastern China has just simply elongated from the main continental region. So when this Indian plate collided against this Asian plate, it just led to this expansion, this kind of bulge out from the main continental plate. This is a smart figure as well, so you can see some animation for better clarity of this collision and how this closing of the ocean occurred. These are the stages of development in a collisional mountain belts. Large terrains are thrust onto a continental block. So these terrains are those microcontinents which we are sitting on top of this oceanic plate, and as this oceanic plate is converging towards the continent, these microcontinents starts to deposit on the continental side, and eventually, if there is any full continent itself is sitting on the oceanic plate, then that will just simply collide against the continental plate, and then you will have a mountain range like a Himalayan mountain. There are more detail given in the book, so please make sure that you read through the book, browse through all these smart figure, and I have posted some videos as well, some educational videos related to this chapter. So please make sure that you go through all of those videos and the text that will help you better understand this whole process of mountain building.